Good afternoon, everyone.
Before we discuss about details in metrology temperature calibrator, let me give very brief introduction about tension instrument. So tension instrument have a mostly three major products. One is temperature sensor, with maximum revenue, that is 60% from the temperature sensors, and another one is cables, that will be approximate 29%, and other one is the different type of heating solutions and heaters, that have a share of revenue approximate 11%. We have a more than 600 employee work in here various unit in Udaipur, Thames, and we have a year of growth of 30%. We have all four units in Rajasthan, Udaipur. All units are dedicated for different type of manufacturing plant. One unit for a different type of temperature sensor like thermocouple, RTD, and other units are for heaters or different type of thermal camera pyrometers. And we have a thermal or furnace department as well. We have a not only in Udaipur, also outside of Udaipur, we have two branches of tension instrument, one in Germany and another one is in Jakarta, which is Tension Asia. So we have all type of necessary certificate for industrial application of various instrument what we manufacture. That is ATIS, NABL, enable accredited laboratory we have. So we our all manufacturing unit and instrument have all the backup of all necessary certificate for critical uses in industrial application. So we have a good marketing network all over the India as well and worldwide. In India, you have all the center like North, East, West, South. You will get our representative for anything contact or any details discussion. We are always there. Also, we have a branch in worldwide like Asia, Mexico, Egypt, Europe, or Southeast Asia. We have our own branch. So today we are going to discuss about details metrology temperature calibrator, and this is very accurate temperature calibrator and have a very low uncertainty means with comparison to our normal standard dry block temperature calibrator. So for a basic dry block temperature calibrator, you know that this is the diagram, my left hand side, that nothing but it is a comparison block means they have a we put the master sensor, we give total chamber, and once it reach the stable temperature, we comparison between our test probe or the master test sensor. So that is the basic dry block calibrator operation. But basic dry block calibrator also have many high uncertainty components. That is your axial uniformity or your loading effect or even your stability or radial uniformity or hysteresis. So lot of other component is there. Also, you have to need your indicator for the comparison based on your master sensor is there and there is a test sensor. So you have to always carry a indicator in your on-site calibration or field laboratory that you have to compare the value. As well, you need the external sensor. So basic advantages of metrology calibration path is that it is very accurate. Even if it has its own internal reference sensor that is very accurate, and it has its own display, 5-inch touchscreen display, so that you don't need carry another recorder or even without master sensor. You just carry your this calibrator to on-site field application even or in laboratory. You just calibrate directly as a measuring source. So metrology calibration is a very good accuracy with respect to our standard the portable driver calibrator. It has a very good and very high accuracy, stability, uniformity, and less loading components with respect to standard dry block temperature calibrator. Also, it has a very lightweight, portable, and fast. It has a very fast speed of response. Like we have a two model. One model provides you up to minus 30 degrees centigrade in 15 minutes, and another one is just within 20 minutes you will get the up to 650 range, and also within 50 minutes it is cooling time for this model. So, or also it is a four-channel readout, built-in readout is there. So you can calibrate four sensor at a time, different type of RTD or thermocouple you can calibrate with this metrology temperature calibrator. So before going to more details, let me discuss some uncertainty components, I will say, or inaccuracy for the dry block, and why metrology is very accurate, and why it is preferable over normal dry block temperature calibrator. Like we know that dry block temperature calibrator nothing but a removable metal insert, and we drill different diameter holes in for the accommodate the sensor inside it, and normally it is portable. The design it is portable, and it is lightweight and very compact design. You can carry around from one location to another, or you can go for on-site calibration and have a relatively good stability, and normally safe and clean. That dry block we don't use any liquid or any other medium to check his performance. So normally it is safe and clean application is there. So as I discussed that we pre-drill the insert. So different type of insert we drill as per customer requirement, or we have our standard design that you can put your different type of diameter sensor inside this insert, and you can check. We can customize the design up to from 25 to 60 dia insert. We can design our own insert, and all have a special material and coating so that it could very thermal homogeneity throughout the region and throughout the temperature range. Normally, that the hole we did in the insert have 0.5 more than the insert diameter. So let us discuss about the uncertainty components. Let's say we are checking a temperature sensor at 400 degrees centigrade. So some parameters during our uncertainty calculation, some components we consider like standard thermometer uncertainty, resolution of the indicator, or hysteresis of these furnaces or calibrator, or uniformity like radial or axial during testing in the furnace, and loading of this block. And another one is the stability, I will say temperature variation during the specific time or stability for some time. So all these components affect our uncertainty calculation in real calculation of a sensor, like this type of contact type sensor, either RTD or thermocouples. So for standard thermometer, we like all these cover like hysteresis, drift, non-linearity, or other components there. So we can consider up to 0.03 degrees centigrade with a confidence level of 95.46% with a coverage factor of K2. Approximately, more or less, we get 0.03 degrees centigrade. And there is a hysteresis effect. Hysteresis effect nothing but when you a calibrator like have a temperature range from 50 degrees so you are checking like 100 degrees. So after 200, again we check the decrease, check the deviation in the your probe, and we can calculate the hysteresis of the specific calibrator. More or less, it will be this component will provide you plus minus 0.05 degrees centigrade. Another one is the resolution of the controlling thermometer. Means what furnace have a resolution. We are giving the resolution up to 0.1 degrees centigrade. That comes a uncertainty components about plus minus 0.5 degrees centigrade it provides. And the third one is the mostly that inhomogeneity of the temperature zone. Means there is two component. One is the axial inhomogeneity, and another one is the radial homogeneity. Axial homogeneity nothing but when you are there is a measuring zone when you are measuring vertically, means you have your temperature sensor deep inside the bottom, and if you pulling upwards from the bottom, and we can check there is a significant temperature gradient along with the from bottom to top side, because the top side is near to ambient, so their losses will be obviously more. So the reason only bottom will get the specific homogeneity temperature zone where actually calibration has been done. So as per standard, approximately 4 mm we consider for axial temperature homogeneity. That component approximately will be within plus minus 0.5 degree centigrade. That will generate a uncertainty component. And another one is the radial homogeneity. That is the temperature difference between the holes, same size hole. As I discussed earlier, that for dry block there is a inside of different diameter hole sizes. So even if it is very high conductivity material inside we use, but still there will be a temperature difference in between the same holes. So that in homogeneity we consider as the radial uniformity. So axial uniformity and radial uniformity comes together and contribute almost plus minus 0.5 uncertainty components. Very important parameters that will be temperature stability for a dry block calibrator. Temperature stability nothing but for a specific period of time, like let's say 30 minutes, we check the deviation in the when the your bath will be stable in a specific temperature, let's say 400 degrees centigrade. So in that specific temperature, if we check for 30 minutes, the maximum value and the minimum value of the temperature, from that we calculate the stability of that furnaces. So you can see there is a graph is there. We check like for 30 minutes we are checking. So at 650, if it is maximum is 650.04 or minimum is 649.96. So it will be 650.05 minus 649.96 divided by 2. So it will be approximate plus minus 0.004 degrees centigrade stability will provide. And there is another very big, I would say that uncertainty component is provided by the loading effect. Loading effect, but all when we are putting any thermocouples or sensor inside the insert, they always some losses is there. There is a heat conducted through the sensor to the environment. Is meaning if environment is 25 and you are putting any sensor inside that insert and you are heating up to 50 degree, 100 degree, with the difference between the temperature sensor, temperature, ambient temperature and your furnace temperature, the losses will be more, the conduction loss will be more. So there is a significant effect on the uncertainty component of the loading effect. So when the number of sensor, means number of drill we are increasing in the insert, or the diameter of the insert is very large, and then the losses will be more, and that losses increases with the higher temperature. So that create a significant uncertainty in your calculation, or uncertainty in reading. It will be approximate plus minus 0.05 degrees centigrade as an uncertainty component is produced. So this is a typical chart in a uncertainty budget for a contact type temperature calibration for 400 degrees centigrade. So you can see all the parameter I calculated. Approximately the value will come with the coverage factor K.2 with 95% confidence level at 0.6 degrees centigrade. So for a basic dry block temperature calibrator, you can see there is an uncertainty about more than plus minus 0.6, sometimes plus minus minus 1 degree centigrade. And if we see, there is a main component is the axial homogeneity that contribute most of the significant value of that uncertainty components, and also the loading effect is there. So there is 3-4 parameter. Actually, basically, if we improve more, then we'll get very low uncertainty, and that exactly we did in metrology temperature calibrator. So in a metrology temperature calibrator, I will discuss how we improve that loading effect and your axial homogeneity as well as radial homogeneity why it is better than our standard temperature calibrator. But before that, we have metrology series, two metrology series we have. One is for high temperature range, that is for 50 degree to 650 degree centigrade, and another one we have minus 40 degree centigrade to 150 degree centigrade, and 650 degree have a display accuracy about plus minus 0.5 degree centigrade, and minus 40 have a display accuracy around plus minus 0.3 degree centigrade. And that is the basic parameter like your uh, this is heating time, cooling time, stability, everything has been mentioned. And this is and the axial uniformity. It is also mentioned for radial uniformity, basic insert construction and depth. So this is the basic two metrology model we offer. That is one for high temperature, that is from 50 degree to 650 degree centigrade, and another one is from minus 40 degree centigrade to 150 degree centigrade. So for our low uncertainty, the basic problem we have, the main component, uncertainty component, is the axial homogeneity. So we use here double zone control for our temperature calibrator. So here all the zone has been differentiated with the two zone control. There is a different controller for the upper zone and another controller from bottom zone. So throughout we confirm that with we control both the zone separately. Means whatever your deviation, if you're controlling here in the main zone, the difference has been fed to our second controller, and second controller uh, confirm that that temperature whatever in the main zone should be on the upper zone. So what happens that the temperature gradient from bottom or to top, it is very much uniform, and gradient is very minimum. Like you can see, if there is a temperature difference in the x-axis, and there is a distance from bottom, you can see. So if you even if from the bottom you go upwards from 10 mm, 20 mm, 30 mm, 40 mm, if we get the single zone control, it will get from a single zone control, you will get big difference, almost three times more non-uniform axial non-uniformity with respect to your double zone control or multi-zone control. Like for this is the graph for the 650 degree centigrade. For 650 degree, if I go to for 100 degree centigrade, so even if we go for the 50 mm or 60 mm, there are only a deviation of 0.1 degree centigrade. Even if we go for the we are checking at 650 degree centigrade at 60 mm from bottom distance, will get approximate 0.5, 0.6 degree centigrade. So that will give you very good uniformity throughout the region, and it is much almost four times better than your single zone control or standard portable dry block temperature calibrator. And second one is the we specially designed and develop our own insert that is based on special material and comes with a different coating to ensure that there should be temperature homogeneity throughout the insert, and that have a good radial uniformity. Even you are checking for different temperature range from minus 40 degree to 150 or 50 degree to 650 degree centigrade. So for 650 AM, metrology will get typical value of 0.05 or 0.07 degree centigrade throughout the range, where in minus 40 to 150 degree will get approximate 0.04 or 0.05 uniformity we can get. Along with that, there is a bright color touchscreen display we get. You can easily navigate your all the sensor parameter. You can get whether it is master sensor, test sensor. You can set your value easily, and you can also define your stability time, holding time, everything. It is very user friendly, so you can easily through touchscreen display and click. You can easily navigate all the process parameter, and you can check all the testing parameters of master and test sensors. There is also auto stepping function is there, means for you can set any 5 points for minus 40 to 150 or 50 to 650 different point you just set, you can set your stabilization time or holding time. So after selection that it will automatically give you one by one reading. Like let's say you are checking from 250 to 1100 degrees centigrade. So first it will come to 250 degrees centigrade, the master sensor, then automatically it will compare, the test sensor masters will be compared and the deviation will be generated. So you just set your set point. If you want any holding time, you just put your holding time, and whatever your stabilization time you just put, and after sometimes you will get your full calibration report, means comparison between your test sensor, all three test sensor and your master sensor will be generated. So you can in this metrology temperature calibrate, you can calibrate at a time 4 thermometer, and we give the 4 dedicated limo connector with that calibrator. You can see there is a 4 limo connector is there. One is dedicated for your external sensor or your master, or three is dedicated for test sensor. So that universal limo connector all type, it is compatible to with all type of RTD sensor like PT100, nickel or copper. Whatever your master sensor is there, it will connect with that sensor, and it gives the all temperature reading here on the display. So in user interface, you can see there is a basic four parameters is there. One is sensor configuration, where you can configure all the serial number, and what is your master sensor serial number or test sensor serial number, or whether it is RTD or thermocouple, you can select. Or also you can select if it is thermocouple K type, R type, whatever your standard thermocouple, you can see that one. And for RTD, you can select whether it is PT100 or PT1000 or different type of RTD, you can select here. And also it's come with different type of configurations. Like for RTD, you can select 2 wire, 3 wire, or 4 wire. For thermocouple, you can select CJC, cold junction compensation facility. Either you can get internal, or you can get external, or you can opt this function. So all parameters you can configure here. Along with unit of what you want, either degree centigrade or Fahrenheit. You can save all this sensor configuration. You can do in basic manual mode. If we go in the manual mode, you can set the temperature, whatever your temperature you just set with the touchscreen display you have. So whatever your temperature you can set here, you show the process temperature of this furnace, its present situation, what is the temperature of this furnace, you can show, you can see here. And that is the 4 channel displays there. You can see there is a master and 3 THT is there. So master, what is the type of sensor, what is this millivolt is generating, and the respective temperature has been shown in that display. So all the details you will get. And also for RTD, you will get whether it is PT100 or 3 wire configuration, or PT100 4 wire configuration, or other type of RTD. You can get the status of that, and the respective ohms and the degree centigrade you will get. So all the details, sensor configuration and the respective temperature you can see here. So after finish the operation, you can save the data, or in the next set point you can reconfigure the sensor whenever you want. So you can easily select all the sensor configuration and take your value. In auto mode, as I discussed already, you can set your all the parameter automatically. You will go the one by one set point. If you fix any holding time, or then it will hold that specific time in that set point, then move to second point. So all facility has been there. Also, there is a facility of external sensor, you want or not. If you want to control the unit with the external sensor, that is also be possible. So that option also be there. So in auto mode or manual mode, both you can do your, you can select your stabilization time, holding time, or the details you want you can put. And at the end of your calibration process has been done both for manual and auto mode. You will generate your data, and you can save that data. Like after you save auto mode or manual mode, you simply, you can see there is a date, time, it is there. So you can select whatever data you want to check. In that data, you can see your master temperature, test temperature, and deviation. All calibration data will be there. Even as per standard ISO say 17225, there are 10 samples, temperature samples at specific temperature also be provided, along with the test master sensor sampling temperature and the test temperature. Both you can get. Also, there is a customizable software and documentation facility is there. Means for software, you can put your all the details, your master sensor details, your test details, your plan details, everything, or including your tag number, serial number. You can put everything, and at the end of this, your testing, you can generate your customizable certificates. For every lab, there is a different type of customizable software or format is there. So if customer want and they tell us what type of specific certificate they want or specific requirement is there, then we can design the software as per them and generate test certificate automatically. After each of the operation, you can get the test certificate. Like here we make for one of our customers, like you can generate your master temperature details, test temperature details. You can automatically generate the tolerance of this sensor, and at the end of the calibration process, whether it is pass or fail, it can be generated. Or even uncertainty calculation, if customer want for your test sensor, then all three certificate for your three test sensor with uncertainty can come with this certificate. So all customizable option documentation is possible with this metrology calibration. So not only metrology calibrator give you the highest accuracy with respect to normal dry block temperature calibrator, also it provided you the customizable software and very easy onboard documentation and easy navigation of the. You can select your sensor configuration and different type of operation or different type of set point you can do. So that is very, I think, based for your on-site calibration, you can do easily, even if without any other recorder or temperature indicator and master sensor, it is still capable of giving you very good low uncertainty. So thank you very much for your participation and your time.